Hi, everyone. I want to go with you about why did I did these slides. So I am a part of a great team, but a very big team. We're a lot of developers. We're working on a huge app, and it's one app that we deploy to the App Store. And we've been writing React Native for a long while now. I think since version 0.12, it was before even Android was supported. So we got some experience with React Native, you could say. So when I think about React Native, I kind of want to do that to my laptop. But you know, after like a few seconds or so, or minutes, I kind of do that because you know our Macs are expensive. So I'm not going to lie to you today. Writing React Native is hard, and it's hard for large-scale apps. Maybe for POCs it's awesome, but when you actually write a production app, which is quite big, you get into these corners sometimes. And it's hard because it adds a layer of abstractions after over the native API. Sorry. It's also hard because the performance sucks. It's hard because it's single-threaded, and sometimes it's a challenge to accomplish things that otherwise would be very simple in regular native apps. For example, efficient lists, and the list goes on and on, right? So if you ever wrote a large-scale React Native app, you probably know this by now. So here is a quote by any React Native developer. You either said it at least once or thought it at least once. And it's the logical conclusion, right? So our only option, basically, to write a truly performant app is to ditch React Native altogether and write native. So I said I'm not going to lie today, and I'm not. It is an option, and it might be a very valid one, depends on your use case, but I claim it's not the only one. So about a year ago, we did some major improvements in our app performance, and what we found out time after time, bug after bug, issue after issue, is that by writing better JavaScript and React performant code, we could solve most of these issues. And today I want to share with you some of those issues. The first one, I call it the send button. So part of our app, it has a chat module. So site owners can talk with their site visitors. So I work for Wix. We're building a platform we're building a building website platform. Sorry. So basically anyone can build their own site, DIY. And after he builds the site, he can add a chat module and talk with his visitors. So the feature is super simple, right? You have the input, and you have the send button, and you want the send button to be disabled when the input is empty, and when the user start typing, the send button become enabled. Super simple, right? But what happened was that it took about a second, sometimes even more than a second, for the button to become enabled after the user started typing. It turned out that we rendered the entire list of chat rooms, while in fact we were inside the single chat room screen. And it happened because we built a new chat room object for all the chat rooms for every change in any of the other chat rooms. So it sounds like a horrible mistake on our part, which is what it was. I'm not denying that. But you know, when you're writing in a functional manner, it looks right and harmless, right? You know, we all know this immutable state. By the way, we solved it by memoizing, which is something that was mentioned here in the conference quite a few times. The second example is the slow rendering of chat messages that arrive in real time. And to demonstrate that, I want to show you a short before and after videos. So this one is the before. So you can hear me typing from another client to this client, and the messages arrive. And it was a bunch of messages, and the last one got in 12 seconds delay since the last typing. I want to show you the after now. Oh, sorry. Quick, right? Okay, so I hope you can see the difference. So the problem was component will receive props was called way too many times. And for each time it got called, it triggered a new render cycle because we called set state inside component will receive props. So that was what caused this huge problem. The last one, I really like that. So our creative and very talented designers challenged us with a very fancy and sleek typing animation. You know, the kind where the bubble heads just appear magically on the screen and the bubble head slides over each other and push the messages up and down and turn auto-magically transform into messages. You know, any front-end developer nightmare, basically. So at first, we tried to go with a naive approach. We did it with JavaScript. We calculated the animation using animated, and it sucked. And then we said, wait a second. We are writing React Native, and React Native has this promise that you can do whatever you want in native if you so wish to. So we did. We tried native, but it sucked as well. And finally, just before giving up, it turns out we could achieve the same slickness as we first wanted by using React Native layout animation. The last one I'm going to tell you here today, remember it's a lightning talk, is, because I have more, is a module loading time. It's a story basically about, a short story about the difference between require and import. So like I said, our app consists of many modules, different modules, independent from each other. So you can think about it as many bundles inside one app. And what we basically did was, for each of these index of these modules, the index file, we just took the imports from the top of the file, and instead of just writing the import list, we required it only when we needed it. And it turns out that this small change, again, all we did was to take the huge list of imports at the top of the file, which you usually find harmless, and we require it only when needed. It saved us, I'm talking about seconds across the app. So this was a fun discovery. And you know, and the list goes on and on and on. I'm sure you can find examples of your own. So what am I saying here? Basically, what I'm saying here, it's not React Native's fault. It's just how React and JavaScript works. It's just a lot easier to see the consequences in React Native because of the way React Native works, because of its architecture with the bridge, and because we're working on mobile devices which have lower CPU powers. And I can prove it to you. So I call this example the good card, bad card. And I wanted to prove that it's also possible to do those horrible mistakes on the web. So I did this GitHub repository. We won't see it because it's a lightning talk, but I really encourage you to check it out if you're interested. Basically, it's a list of cards, 100, nothing crazy, and each card has an input field. And in the bad card example, you can see that you type and you feel the slowness. The keyboard doesn't react the way you'd expect. And for the good card, it works perfectly. And the only difference between the two is one single line of code. So I challenge you to find this single line of code, and you will see that you can have bad performances with the same things also in the web. So it's up to us as React Native developers. We can't just use the regular paradigms of React Native, which is fine, but we need to be much more careful and responsible React developers. Okay, so most of the things I said here, if you do it on the web, you won't see any effect. But on React Native, you will. So you need to be much more careful. And you can do it by, first of all, know your crucial app flows and monitor them. So it doesn't matter how you monitor your app, just make sure that your crucial app flows, you monitor them, and whenever the performance starts to become worse, you will get notified. Avoid writing anonymous function as props. This could have huge impact in your app. Know your components. Don't just write pure component and think that you solved the issue. In the bad card, good card example, I used pure components and it still didn't do the trick because of how pure component works. And know your component's lifecycle method. Each component is different and might need a different lifecycle method. Last but not least, know your reducers. So for those of you who are familiar with Redux, I have a really cool analogy I want to show you here today between reducers and databases. So let's start with database. So let's say we have a table with many writes to one field and many reads to another field on the same table. So the problem is that any write locks the table and delays the read, right? The solution is to separate into two tables. Pretty easy. Now in the reducer world, let's say we have a lot of actions that changes a field in the state. It can be also an inner field of some object. But not many reads to this field. So any state change triggers the rendering cycle and might slow your app. The solution here is also simple. Just separate into two reducers and combine them when needed. So by now, you might think, okay, everything you said here is pretty vague. It's like your examples. I don't know where to start. I don't know how do I profile my React Native app? So I have really, really good news for you. And it's really, really easy. The help is just around the corner. And it's called Why Did You Update? Why Did You Update is a very cool library that I urge you to check out. Basically what it does, it monkey patch React, and it prints to the console every time you do an unnecessary render. And it tells you exactly like, why did you do this potentially unnecessary render? So I urge you to check it out. And basically I'm done. So thank you very much for listening. And if you're interested in this talk, or if you want to learn more about our use cases and case studies, I also posted on Medium, on HackerNoon, so you're invited. And I will Twitter it on the hashtag of ReactNext if you're interested. Thank you.